Hello everyone. This video we are going to learn about parameterized ADTs. Earlier to this concept we were discussed about abstract data types and abstract data types which are not having any parameter we were discussed. In this video parameterized ADTs. ADT what we are going to take that will have parameters. Right now we should be able to design a stack abstract data type that can store any scalar type elements rather than the required to write a separate stack abstraction for every different scalar type. So that means we'll be going to take scalar type element as a parameter in the ADT. So note that this is only an issue for static typed languages. So we were discussed in the second unit, there are videos, uh, what are static typed languages and what are dynamic typed languages. So dynamic typed languages like Ruby, any stack implicitly can store any type elements. So we need not to separate pass any parameter and saying that it is parameterized ADT. So what the point you have to understand over is parameterized ADTs are supported only in static typed languages. No dynamic typed language will support parameterized ADTs. Why? The reason is that can store any type of elements implicitly. So there is no requirement to pass parameter explicitly. So in fact, different elements of the stack could be different types. So altogether, parameterized ADTs are supported by C++, Java and C#. So Ruby it will not support parameterized ADTs. Now let's see how it will run the code. So this is what parameterized ADTs. Now I am passing this scalar element and it is having type data type for this element which is integer. Now I am talking about again stack implementation as far as syllabus is concerned. So stack implementation using parameterized ADT in C++ language. Stack int size, what does it mean? It is what? A constructor. It is what? A constructor. Now the constructor is having some parameter and these all things already we come across in C++. Now the declaration for a stack object now may appear as follows. Now stack stk. Stk is object of stack class, right? Now 150 is what? Size of the stack. That's what constructor is having size, right? Now that's what. Now uh, the class definition for stack can include both constructors. So users can use the default size stack or specify some other size. The element type of the stack can be made generic by making the class as a templated class. And this is one of the feature of C++. So here we were taken 150, right? So when the element type of the stack can be made generic by making the class as template classes, then the element type can be template parameter. So I'll show you the example. See the example parameterized ADT in C++. We'll be taking template class and the type is template parameter and general class. I'll show you the difference where, see now here I'm not passing any size. Did you notice this, that I did not pass any, but it is a what, it is what parameterized ADT. Now how I'm saying it is an empty, but I'm saying it is a parameterized ADT. The reason why it is parameterized ADT is I'm taking a constructor for a given number of elements which is which is size. This is what stack int size, it's a constructor for a given number of elements. Now this is what a constructor for 100 elements stack. Now this is what about C++. Now you can have a look into the code how type parameter of template class is used And this is what the constructor for a given number of elements of this size. And the next is about Java ADTs. Java supports a form of parameterized ADT in which the generic parameters must be classes. The most common generic types are collection types such as linked list and array list, which were in the Java class library before support for generics was added. Now you can have a look. We'll be creating an array list to the object. So array list, my array, new array list to create object for array list. And we are creating an element which is the element myArray.add 0 comma new integer 47. Now get first object which is integer myInt is equal to integer myArray.get 0. In Java 5.0, the collection classes the most commonly used of which is array list became a generic class. Such classes are instantiated by calling new on the class constructor and passing it the generic parameter in pointed brackets. So that's what you can find it over there. Array list integer myArray is equal to new array list integer. So this is what the array list class can be instantiated to store integer object with the following statement. So Java 5.0 also includes generic collections for linked list. So this is what your array list. Linked list is what not only linked list, queues and sets, also generic collections are included. Users also can define generic classes in Java. So using of this type of code. So this is what generic classes are can be taken in Java, supported in Java by by implementing array list, or else you can take even sets, dictionaries. So all these things are possible through generic classes to define the size of an array, or the size of and the data structure what we are taking. So coming to the C sharp, the first version of C sharp defined collection classes that stored objects of any class. These were array list, stack and queue. These classes had the same problems as the collection of pre-Java 5.0. Generic classes were added into C sharp. The predefined generic collections are array, list, stack, queue and dictionary. And one capability of the user-defined C sharp generic collections is that any of them can be defined to allow its elements to be indexing or accessed through subscripting. Although the indexes are usually integers, an alternative is to use strings as indexes. This is for C sharp. C sharp is what? We'll take generic classes as an additional feature to C sharp, and predefined generic collections are array, list, stack and queue.